dear students. Happy Teachers Day to all. So let us learn about how to determine support reactions of propped cantilever beam. Right. First of all, this beam is statically indeterminate beam. Right. So how it is? Let us see. So the reactions for fixed support are 3. And for roller support we have 1 reaction, right? So the number of reactions are 4 and number of equilibrium conditions are 3, right? So it is 4 minus 3 is equal to 1. So static indeterminacy of this particular beam is 1, right? So for statically indeterminate structure, how to determine support reactions, right? So this structure is statically indeterminate to 1 degree, right? Now, how to determine support reactions for this? By just moment area method, right? So, your first step is to select a redundant, right? So, if I select redundant as RB, then my beam will be the cantilever beam, right? And the cantilever beam is statically determinate because for this beam now we have only 3 reactions: vertical, horizontal and moment, and we have also 3 equilibrium condition: sigma fx, sigma fy, and moment about any point is 0, right? So now this beam is statically determinate beam, right? So I selected RB as a redundant. And what about the deflected shape of this beam, right? It is like this. Now statically determinate beam, and I have selected this redundant, that is RB. Plus, now wherever the redundant is applied, you have to apply a unit action over here, right? So I have applied a unit action over here as a RB, right? Now due to this unit action, we have upward deflection, right? Now applied redundant action, that is RB, is equal to 1 unit. So now we have the combination of these 2 beams, right? Now how to determine redundant RB, right? First of all, you have to draw bending moment diagram. Now bending moment diagram for this particular beam, that is, here we have anti-clockwise 10 kilonewton into meter. How it is? 10 clockwise, and the reactive moment will be the anti-clockwise 10 kilonewton into meter, and the diagram is negative because we have left side anti-clockwise moment. So the diagram is negative. Moment at C is 0, moment at B is also 0. Plus, now we applied redundant action over here. What about the moment over here? It is RB into 2. Anti-clockwise, right? RB into 2 anti-clockwise over here at A end. Okay, to balance it, I applied clockwise moment, right? So clockwise RB into 2. So we have left side clockwise moment and it is positive moment. So this is about the diagram of this beam, right? Bending moment diagram for statically determinate beam plus bending moment diagram due to applied unit action. Okay, so whatever the redundant is selected, at that redundant you have to apply unit action. Here I have selected RB, so I have given RB is equal to 1 unit, right? So now next, so deflection BB, that is the moment of area of M over EI diagram about B, and deflection BB, that is what? That is due to the statically determinate beam, right? So let us determine deflection of statically determinate cantilever beam, right? So that is what? Area multiplied by the perpendicular distance of that area from B point, that is equal to 1/2 base into height, that is area of this right angle triangle, multiplied by the perpendicular distance is 2/3 of 1 plus 1 from B point, right? So the deflection due to the loading of that cantilever beam, that is 8.33 over EI. Now this is the deflection due to the unit action of the redundant RB, right? So the moment of area of M over the EI diagram about E. Same way, area multiplied by the perpendicular distance of the area from B point, right? Now the area of this triangle is 1/2 into base, that is 2 meter, into height, it is equal to 2 RB over EI, multiply by 2/3 of 2. So what I get? 1.33 RB over EI, right? So now next, what about the perpendicular distance? It is 2/3 of 2, right? Now next, RB, that is equal to this deflection that is due to the statically determinate beam, and this is due to the unit action, right? So 8.33 over 1.33. So finally the RB is equal to 6.26 kilonewton. Now once the redundant is determined, finally you can determine the other reactions by equilibrium condition only, because now we have only 3 unknowns, right? So this is determined 6.26. So other unknowns automatically we can determine. How it is? Apply sigma Fi is equal to 0. It is 10 minus 6.26 is equal to 3.74. And moment about A. How I determined this one? 6.26 into 2. I have taken moment about A. 6.26 into 2 anti-clockwise, right? Minus 10 into 1 clockwise. So is equal to 2.52 kilonewton into meter, right? So this is moment about A. So we determined all reactions of proper cantilever beam by moment area method. Hope my dear student it is clear. If you have any query, any questions, you can mail me, and please don't forget to like, share and subscribe. Thank you for watching.